The next question here is a sample of sodium nitrate weighing 0.38 grams is placed in 250 ml of volumetric flask. The flask is then filled with water to mark on the neck. This mark on the neck actually says that it is 250 ml. So don't get confused. This statement says that volume is made equal to 250 ml. What is the molarity? Now, in many assignments, I have found you just substitute the values without writing the formula. In all questions, when you submit the assignment, first you will be writing the formula and then you will substitute the values. You will write the formula. Molarity is equal to number of moles of solute divided by volume of solution in liters. Number of moles, given mass 0.38 divided by molar mass. Molar mass of NaNO3 will be sodium 23 plus 14 nitrogen plus 3 times 16, 48. You get 82. No. 23 plus 14 plus 48. 85.
Sir, 85.
Right. So 85. So given mass over molar mass. Okay. Here also you will not write just here. You will write, and remember, in 11th it might work, in 12th it will not work if you just substitute the values without writing. So if I am talking about board perspective, you will write it as mass divided by molar mass. And then you will write volume of solution in liters. That will be mass 0.38 divided by molar mass 85 divided by volume in liter means 250 divided by 1000, because 250 is milliliters, not liters. Okay. And when you simplify this one, you will get answer as 0.185 something in actual, but 0.0, sorry, 0.018 and something. We take only up to here. And because it is molarity, you will write mole per liter. That is the unit, or just 0.018 capital M. Capital M itself says this is molarity, and this is also used as unit.
Sir, what does small m denote, sir? It was in question number 4 of
Molality.
assignment 9.
Molality.
Molality.
Small m is molality, capital M is molarity.
Sir, can you discuss the fourth question of assignment 9, sir? Because I think, sir, there wasn't adequate data to find out, sir,
What
the
was the
answer for that.
question? So what was the question?
Sir, I'll have to check the assignment, sir. I have
Let me
written the answer.
Okay, just a second.
Sir, it was given like molality of the solution was 2.5 m, and we had to calculate number of moles and 18 gram of uh, the solute was given.
Just let me see.
So can you please tell question 4 of assignment 9?
Just first, tell me which assignment you were talking about.
Sir, 9th.
Assignment 9.
So I think question 4 की बात कर रहे हो.
Okay. Question 4. What is the mole
Yes.
fraction of the solute in 2.5 m aqueous solution? No, everything is given. Basically, it is aqueous solution, so it means remaining is water. Okay. So
Yes, sir. Sir,
You will solve it like.
okay, sir. Sir, that is where I was getting confused. Like for 1000 gram, I wasn't able to convert it to moles.
So 1000 gram given mass divided by molar mass,
Eh,
1000
Yes,
divided by
sir.
88.
Sir, but
1000
then
by
you said
88.
yes, sir. You said aqua, sir. I didn't pay attention to that word. So that is why I wasn't able to understand which thing is it denoting.
Aqueous means that there is water.
Yes, sir. That is true.
So 2.5 mole and you will get 55.56 moles there. 1000 divided by 18 will give you 55.5555, which you will write
Sir,
as
so it means
55.5.
Na plus Nb is 55.5.
No, basically, if you see 2.5 m aqueous solution means the solute is negligible as compared to water. Okay, so you will write 2. Okay, I'm telling you, even you don't need to consider as negligible. Just let me explain on. Yeah. Understand the difference between molarity and molality. Here, molality is given. So first I'm explaining molarity so that you can understand the difference. If this is the whole solution and this much is a solute, this is solvent, this whole is solution. In case of molarity, capital M, okay, molarity will be number of moles of solute divided by volume of
Volume of solution in
solute.
liters.
Yeah, obviously in liter. But if I'm talking about molality and I consider the same arrangement, solute, solvent, then in this case, the molality, small m will be number of moles, same thing, but mass of solvent.
Yes, sir.
So in case
Means just this part. Now, if question says 2.5 m, it means there are 2.5 moles of solute by definition in
kg solvent.
1 kg of water. And what is this water? This is solvent only,
Yes, sir.
not solution. So it means you have 1 kg of water as solvent. So you need to convert this into moles. So moles of water will be given mass, that is 1000 grams. 1 kg will be 1000 grams divided by molar mass, which will give you
1000 by 2.
55.5555, which you will write 55.56. So number of moles of solute, whatever solute is there, say S, 2.5 moles, and number of moles of water, 55.56. So mole fraction of solute will be number of moles of solute divided by total number of moles.
Yes, sir.
This will be
55.5 plus 2.5.
So total moles will be sum of those, not just 55.5.
Okay, sir.
A few questions basically are from that assignment, what I am going to do today. So here there should not be any confusion because here solvent is different, solute is different in case of molality. So you don't need to even do approximation. Everything is given. Next question, and these type of questions are slightly tricky. Most of the students have done this correctly, but a few students have not done this correctly. This is question of your assignment. Calculate the molality. So when you are considering the molality, always think that there is a chance of error, mistake basically, and the mistake will be always considering in the amount of solvent. This is 500 ml solution. So you cannot use this as the volume of solvent. Okay. The density is given. You need molality. You can calculate the mass from volume because density is mass over volume. Volume is given 500 milliliters. Density is given 1. Mass will be calculated. So mass, but that mass will be of solution, not of solvent. To get the mass of solvent, you will say mass of solution minus mass of solute. And mass of solute is given 20.7 grams. Potassium carbonate is solute. So you will say mass here will be volume into density. That is 500 milliliters into 1 gram per milliliter. That is 500 grams. So mass of solution 500 grams minus mass of solute 20.7 grams. That is 479.3
479.3.
grams. This is the mass of solvent which you will be using in formula. Molality is equal to number of moles of potassium carbonate divided by mass of solvent in kg. Number of moles of potassium carbonate will be given mass of solute divided by molar mass of K2CO3. When you calculate, it will come out around 138. 39
Yes,
to
sir.
the 78 plus 12, 90 plus 48, 138. Okay. Given mass upon molar mass, and mass of solvent in kg will be 479.3 divided by 1000. Because it is in gram, you have to convert it into kilogram. When you solve this one, you will get 0.313. 0.313. Either you say small m, which is unit of molality, yeah, indicating that this is molality, or you can write mole per kg. Here in the numerator, you have moles. In the denominator, you have mass in kg. So mole per kg is the unit. Anything not clear, let me know. Any confusion in any step?
Sir, in this question, I directly calculated the number of moles of K2CO3. So, sir, वो वैसे नहीं हो सकता?
Absolutely fine. You can first calculate the moles and then substitute, or you can do like this. Okay. That is, I think, a better approach. What you are saying, if you first calculate the number of moles of solute and first calculate the mass of solvent in kg and then use the formula, that is a better approach.
Okay, sir.
So in this case, what I have done, I have calculated the mass of the solution first. Why I needed mass of solution? Because I need mass of solvent. Mass of solvent I can get by mass of solution minus mass of solute, 479.3. After that, I calculated number of moles of K2CO3. Okay, divided these moles by mass in kg, got the answer. Next, calculate the concentration of nitric acid in moles per liter. It means the question asks you to calculate the molarity. Moles per liter is number of moles divided by volume of solution in liters. Effectively, question is just asking you to calculate molarity. Okay. In a sample which has a density is given 1.41 gram per ml and mass percent is given. Okay. Nitric acid mass percent 16. It means out of 100 grams of HNO3, this is mass percent. Out of 100 grams of HNO3, there will be actual HNO3 69 grams only. Rest will be water. you will say, assuming we have 100 grams of HNO3, and this keyword, don't forget to write it, solution. 100 gram is whole solution, out of which HNO3 is 69 gram, which is solute. 100 gram is whole solution. HNO3 is only 69 gram, that is solute here. Hence, HNO3, mass of HNO3 will be 69 grams. Now think about the formula of molarity. Number of moles of HNO3 solute divided by volume of solution in liters. It means 100 gram of solution, and this is common mistake, so everyone needs to pay attention here. 100 gram is solution. Solution is not 69 grams, remember. In assignment also, a few students have done this mistake, and this is common mistake every year if the students don't understand it. Understand it diagrammatically. You say that you have 100 grams of solution. This is 100 gram. And pictorially, just to represent, I say this much. 69 grams is HNO3. So 100 gram is actually solution. And 69 gram is HNO3. So you need to understand this difference. So to calculate the volume of the solution, you will be using 100, not 69. To get the number of moles of solute, you will be using 69. Both are masses, but understand the difference. So number of moles of solute, why we are calculating moles? Because we need molarity of solute, that is HNO3, will be, you will write the formula and then you will substitute the values. I am not writing the formula, you will write. Given mass upon molar mass of HNO3, which will come out to be 63. From here, 1 plus 14 plus 48 will give you 63. You don't need to simplify this one. Okay, this is molar mass. You just write mole per or grams per mole. Molar mass, number of moles. Sorry, these are moles. These many moles. Why I am saying you don't need to simplify? Because if you simplify here, there might be some approximation. The value will come in decimals, and there might be some approximation which can deviate your answer from the correct answer, actual answer. Then you need to calculate the volume of the solution, because you need to calculate molarity, volume of the solution in liters. But you know mass of the solution. You can convert this mass to volume by using the same formula, density equals to mass over volume.
Mass upon volume.
Okay, so mass of solution will be density into, sorry, volume of solution. Volume of solution will be mass of the solution divided by density. Mass of the solution is 100 grams, which you have assumed, total 100 grams, divided by density 1.41. So this will be the volume, but it will be in milliliters, because mass is given in grams we have assumed, and density is in gram per milliliter. So unit here will be milliliter. So make sure that you don't forget to convert it into liters. Otherwise, the answer will not be correct. It means it will be 100 divided by 1.41 into 1000 liters. You divided it by 1000. converted to liters. Now you know the number of moles and you know the volume of solution in liters. You apply the formula that molarity is equal to number of moles divided by volume of solution. So it will be 69 divided by 63 divided by 100, or you can simplify this as 1 divided by 14.1. Okay, 0 got cancelled. 1 divided by 14.1. 1 divided by 14.1, that is 69 divided by 63 into 14.1. When you calculate, you will get answer as 15.44, which makes sense because this will be slightly greater than 1. And if you multiply 14.1 with slightly greater than 1, it will be slightly greater than 14.1, that is 15.44. Either you write capital M or moles per liter. Both are correct. Any step not clear, let me know. These type of questions are very important. If you can do these type of questions, all earlier questions based on molarity will be done. Yes.
The volume of solution.
Volume of solution. Okay. Volume of solution we got. We said that the whole volume mass of the solution is 100 grams. Why we considered 100 grams first of all? Because it is given the HNO3 is 69%. That's why it makes sense that if HNO3 is 69% by mass, we can consider whole mass as 100 gram. Out of that, 69 grams will be HNO3. So that's why we said whole mass of the solution is 69 grams, out of which 69 gram is HNO3. Up to here, is that clear?
Yes, sir.
Okay. But in molarity formula, you don't need mass. You need volume of solution in liters. So volume of solution from 100 grams, you can convert it to volume by using formula density is equal to mass over
Volume.
So from here, I calculated volume of the solution equals to mass into density, that is 100 into density. I think I had to calculate mass. No, volume equals to mass over density. That is 100 divided by 1.41. But this will be in milliliters. So I converted this to liters by dividing it by 1000. That is 1 by 14.1 liters. Is that clear?
Yes, sir.
This is the question basically we have done. 2.5 m aqueous solution mole fraction, which I have explained. Next question. How many grams of sodium carbonate should be dissolved to make 100 centimeter cube of 0.15 m Na2CO3 solution? Question is very easy. You just need to understand what is given, what is asked. Question says how many grams. So if you can get the moles of Na2CO3, you can convert it to grams.
So we
You
can
know the
multiply 100 centimeter cube is 100 ml. So we can multiply it by 0.15 to get millimoles.
Right, right. Yes, to get the millimoles. That is one way, okay? Another way is to understand, however, both are same things, okay? What you are saying and what I am saying, same thing. This means the molarity is 0.15. It actually means molarity is 0.15. And molarity formula is number of moles of sodium carbonate divided by volume of solution in liters. So molarity is 0.15. Number of moles of Na2CO3 you have to calculate, and volume of solution in liter, 100 milliliter. Centimeter cube means milliliter. Milliliter or cc, all these are same thing. Cc means cubic centimeter, which is centimeter cube, or milliliter, same thing. So 100 milliliter when converted to liter will be 100 divided by 1000. That is 0.1, 0.1 liter. So number of moles of Na2CO3 will be 0.015. And you know the relationship between mass and moles. Okay? When you convert the moles to mass, you multiply moles by molar mass. You need to remember that diagram. Or you just apply the formula moles equals to given mass upon molar mass, even then it is same thing actually. If you write in terms of moles, moles will be mass over molar mass, same formula you are using. Substitute the values. Na2CO3 will be 23 to the 46 plus 12 plus 48, 50 plus 40, 60 plus 46, 108. Then you multiply, you will get 1.59.
Sir, sir, how did you write n upon 0.1?
Okay. To get the mass of Na2CO3, first I am trying to calculate the number of moles. I am trying to calculate this thing. Okay. So I have written this as N. Molarity is given 0.15. Number of moles I have to calculate. I need number of moles to calculate the mass. If I know the moles, I can convert it to mass. That's why. And volume of the solution in liter is 100 milliliter. 100 milliliter is equal to 0.1 liter. So this I have written here.
Okay, sir.
If any step is not clear, you can let me know. Okay. And your answer is correct, 1.59, because if it would have been 0.015 into 100, okay, just 100, then it would have been 1.5. Okay. Now it is slightly more than 100. It means 100.59 is correct answer. This approximation technique is very useful in objective type questions. As I have told you in earlier classes, also in objective type questions, in competitive examinations, toppers don't do calculations every time. Okay, you can understand the answer, correct answer, just by approximation without doing calculation and saving time. And sometimes it is other way around. The students start solving the problem instead of saying that they can do reverse tracking. They can just use the given values and easily get the answer. They can just verify which value is correct out of the four. Okay. Next question, and this question appears quite a few times in your examination. Very simple question. It looks tough only. A sample of drinking water was found to be severely contaminated with chloroform, CHCl3, supposed to be carcinogenic in nature. This statement is basically useless. It doesn't give you any information except that the solute is CHCl3. Okay? Carcinogenic means causing cancer, cancerous. The level of contamination was 15 ppm by mass. 15 parts per million by mass means if the whole solution, whole water is 1 million grams ppm by mass, okay? 1 million grams water will have 15 grams chloroform as impurity. This is what 15 ppm means here. 15 parts per million. Per million means you have 1 million grams and 15 parts, that is 15 gram chloroform. So you will use this information. Express this as percent. So if out of 1 million you have 15 gram, then out of 100, how many grams? You will apply same, proportional, uh, your questions which you have done in 7th grade, 8th grade, okay, proportionality, inverse proportionality. In proportionality, ratio is constant. In inverse proportion, multiplication is constant. Do you remember that or not from your previous grades? That in direct proportionality, the ratio remains constant of the same quantities. In inverse proportion, their product remains constant. That means you don't remember that. No answers. So you need to at least learn that. If it is direct proportion, there are two ways you can do. Either you can apply unitary method. The unitary method will be that because you have to calculate percent means out of 100 you have to calculate. You will apply unitary method that in 1 million grams of water, CaCl3 is 15 grams, hence in 100 grams. Why in 100 grams? Because we have to calculate percentage. 15 divided by 1 million into 100, that is 15 into 10 to the power minus 4. Why 10 to the power minus 4? This will be 10 to the power minus 6. It will be 10 power 2. So 10 power minus 6 plus 2 will give you minus 4. That is 1.5 into 10 to the power minus 3. Okay. In physical chemistry and in numericals of organic chemistry as well. Sorry. Your calculations must be strong. So this much is the percentage. Out of 1 million, you have 15. Out of 100, you will have how much? That will become the percentage. Out of 1, it will become fraction. So fraction is out of 1, percentage out of 100, ppm out of 1 million. Next, determine the molality of chloroform in the water sample. Now, molality is what? Number of moles divided by
On
mass
mass
of
in
solvent,
kilos.
right? So you know that. And you know these also. 1 million gram of water will be equal to 1 million milliliters of water. Why this will be so? Let me ask someone. Why I am saying 1 million gram of water will be equal to 1 million milliliters of water? I need answer from Atman. Unmute
Here,
your mic.
got answer from the density formula.
Okay, what is that formula?
The density is equal to mass upon volume.
Okay, and what is the density?
1 gram per milliliter.
Right. So the water's density is 1 gram per milliliter. That's why 1 gram will be equal to 1 ml. 1 million gram will be 1 million ml. Okay. Now remember, do you need this thing? You don't need, because in molality, you need mass. Okay. The conversion is fine. Your answer is correct. We don't need a milliliter here because we are calculating molality, and molality is nothing but number of moles of solute, that is here CHCl3, divided by mass of solvent in kg. So number of moles of solute, you can calculate answer by both. Either you consider 100-gram water and you have in 100-gram 1.5 into 10 to the power minus 3 grams of CaCl3. In 100-gram, these many grams. That's why we have written percentage, because this is out of 100 grams. Or you can use in 1 million grams, you have 15 grams. Same thing. Basically, ratio is same. You can use any information. Okay, so I'm considering this one. Means mass in kilograms, 1000 kilograms. I have converted grams to kilogram, divided by 1000. And 15 grams will be equals to mass divided by molar mass of CaCl3 as number of moles. So I'm calculating moles here. CHCl3 molar mass will be 12 plus 1 plus 3 times 35.5, 35, 100, 506.5, 119.5. This will be moles. Up to here, any confusion, let me know. Why I am doing so? Because I am calculating molality. Molality is number of moles divided by mass of solvent in kg. That's why I am doing so. Now you might say that this 1000 kg is mass of whole solution, but we need mass of only solvent. Just see here. This is 1000 kg and this is 15 gram means 0.1015 kg. This is negligible. Almost zero as compared to 1000 kilograms. Even with respect to 100 gram, it is negligible, 0.015. For 1000 grams, it is almost negligible. So whatever is the mass of solution, that is equal to mass of solvent. It is mass of solution, which is approximately equal to mass of solvent. That's why I am using this. So molality will be number of moles of chloroform, which I have calculated as given mass over molar mass, divided by mass of solvent in kg, that is 1000.
Excuse me, sir.
Yes.
Sir, if there are questions which involve ppm as units, sir, then which things will we consider as units? So, like in this case, you considered grams. Sir,
Mostly mass.
15
If it is not given, then mass, but otherwise it will be mentioned in terms of molecules, for example. In few questions, it will be given that
Yes.
these many molecules have these many molecules. Then you need to consider molecules.
So, but then we will apply the formula like in denominator, we multiply 10 to the power 6 and then find ppm.
Same thing. The
Yes.
concept will remain same.
Okay, sir.
That out of 1 million entities, there will be 15 entities, for example, 15 ppm. So if we are talking about atoms, out of 1 million atoms, 15 atoms will be of different compound. If we are talking about by mass, 1 million grams will have 15 grams of something else.
Yes,
But
sir.
that will be very clear from the question, what we need to consider. So this will give you the answer. Number of moles of CaCl3 divided by mass of the solution in kg. When you solve this one, now approximately you can calculate, right? This is approximately 120. So 15 divided by, if you see 120 means 12, 15 ones are, 15 twos are, 15 fives are. So it will be 1.25. If it is 15 by 120, 15 by 12. If it is 15 by 120, it will be 0.125. Approximately, it will be 0.125 into 10 to the power minus 3. That is 1.25 into 10 to the power minus 4. Approximate answer. Okay. If 15 by 12 is 1.25, 15 by 120 will be 0.125. And this 1000 10 to the power 3 when goes into numerator will become 10 to the power minus 3. So if I go back, you will see the answer is 1.255 into 10 to the power minus 4. Units will be mole per kilogram as it is molality, or you can just write a small m. Is every step clear, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, these last two questions are very important. These are from NCERT. Okay, question number 35 and 34. This question says calcium carbonate reacts with aqueous AH according to this reaction. And you have used this reaction in calculation of limiting reagent in one of the previous questions. Okay. So we calculated limiting reagent and we did stoichiometric calculations. Similar question. The only difference here is that the values given are in terms of molarity, nothing else. And whenever it is given like in this form, 0.25 ml of 0.75 m, it is actually the moles. When you multiply these two, because here it is milliliter, you will get millimoles. So if you multiply these two values, you will always get moles, here millimoles. And the reason is because the formula molarity is equal to number of moles given by divided by volume of the solution in liters. So molarity is the number of moles of the solute divided by volume of the solution. Okay. So molarity is given volume is given. If you multiply these two, you will get number of moles. So whenever you see this type of statement, it means this is nothing but number of moles or number of millimoles depending on the unit. So calculate the number of moles of HCl required. So what mass of CaCO3 is required to react completely with this much HCl? So it means millimoles of HCl are 25 into 0.75. Okay. So 25, 0.75 can be written as 3 by 4 means 75 by 4 millimoles.
So,
Means
what is the value of millimoles, sir, in moles?
10 to the power minus 3. So
Okay, so
one
same
mole,
conversion.
just
Okay,
conversion, milli conversion,
okay, sir. Okay, sir.
into 10 to the power minus 3 moles. Okay. 1 milliliter is equal to 1 by 1000 liters. Similarly, here 1 millimole will be equal to 1 by 1000 mole, or 1 by 1000 can be written as 10 to the power minus 3 in multiplication. So these many moles are there. Now go to same concept of stoichiometric calculations, that 2 moles of HCl require 1 mole of calcium carbonate. 2 moles of HCl in balanced equation require 1 mole of calcium carbonate. Hence, 75 by 4 into 10 to the power minus 3 moles of HCl will require 1 by 2 into 75 by 4 into 10 to the power minus 3 moles of calcium carbonate. If you face problem in unitary method, do practice. Okay, it is required. If you are not very good in unitary method, I would suggest that you do some mathematics problems based on that. It means it will be 75 divided by 8 into 10 to the power minus 3 moles. Right? What is asked? What mass of calcium carbonate? So you calculated just the moles. These are the moles. 75 by 8 into 10 power minus 3 moles. it means you need to multiply it by its molar mass to get the mass. So you got moles of calcium carbonate as 75 by 8 into 10 to the power minus 3. Hence, mass of calcium carbonate will be moles into molar mass. You know the conversion from mole to mass. The conversion was mole multiplied by molar mass. You remember that. It means it will be 75 by 8 into 10 to the power minus 3 into molar mass of calcium carbonate 100. That is 75 into 0.1 divided by 8. That is 7.5 divided by 8. That is 8 9s are 72, 8 3s are 24. I think it should be 9.3 something. Okay. Yeah, 9.4. So it will be 9.3 something. So it will be rounded off. 8 7s are, yeah. Grams. Exact value will be 9.375. When rounded off will be 9.94. 0.9375. When approximated, it will give you 0.94 gram calcium carbonate. Is every step clear? All steps must be clear.
Sir, please show the next slide once again. Yes, sir. Sure.
So the approach is you required mass. Mass you calculated from moles, and moles you got from the stoichiometric calculation. Yeah. Before stoichiometric calculation, you got the concept that how many moles of HCl were there. Moles of HCl. You did a stoichiometric calculation, unity method. You get moles of calcium carbonate. From moles of calcium carbonate, you multiplied by molar mass of calcium carbonate to get the mass. So this is the
So is it
path you have
necessary to
followed.
make this?
No, you don't need to draw this path. I am just telling you how you need to understand, how you need to approach. You don't need to draw this path in answer. This is for you to understand how to attack these type of questions, which path you need to follow. Next question. And this is a very important question, and certainly 50% students will get this question in their exam from your NCERT exercise. And pay attention, don't just sit back. Nothing new, but application is slightly different. A welding fuel gas contains carbon and hydrogen only. This is important to understand that there is nothing else. Burning a small sample of it in oxygen gives 3.38 grams of carbon dioxide and 0.690 gram of water, and no other products. No other products. Okay. And you know there won't be any other products, because if it is hydrocarbon, I have told you the generic formula, generic equation. If it is CXHY plus X plus Y by 4 O2 will give you XCO2 plus Y by 2 H2. So there will be carbon dioxide and water only. carbon dioxide and water if you burn a hydrocarbon. Because there is carbon and hydrogen only, it means it is a hydrocarbon. But we are not going into those details. We are going in some other calculations. Why? Because if it is something CXHY and it is reacted with O2 and it gives you CO2 and H. Okay. CO2 is this much, 3.38 grams, and water is 0.690 grams. If you can understand the concept, the question is very easy. Now it says a volume of 10 liter measured at STP of this welding gas, this gas, is found to weigh 11.6 grams. Calculate empirical formula, molar mass of the gas, and molecular formula. Means
So,
for this gas, you need to calculate empirical formula, molar mass, and molecular formula. Yes,
so we can do it like that. That in CO2, all the carbon is coming from like the hydrocarbon. So moles
yes,
of C are.
exactly, exactly. Yeah, that is the concept we need to understand, because it said there is no other compound and only carbon and hydrogen. So whatever carbon here is, this carbon is from the compound. Similarly, whatever hydrogen here is, that is from this compound. Oxygen obviously came in from atmosphere. This
So
carbon
it's a
and
hydrocarbon.
hydrogen, yes, oxygen
Okay.
will come from the atmosphere in CO2 and H2O. Okay? But carbon and hydrogen will essentially be from the hydrocarbon, okay? Which is the welding fuel gas. Welding fuel gas contains carbon and hydrogen only. It means this is a hydrocarbon. So it makes our job easier. How? Because we can calculate how much carbon is there in 3.38 grams. We know the relationship that in 44 grams of carbon dioxide, carbon is 12 grams. Is that clear to you or not?
Yes, sir.
Okay.
Yes, sir.
So we will say that if we consider CO2, CO2 is 12 plus twice of 16, that is 44. Out of these 44, carbon is 12. So we will say as 44 grams of CO2 contains 12 grams carbon, hence 3.38 grams of carbon dioxide will contain 12 by 44 into 3.38 grams of carbon. Why we are calculating carbon? Because for empirical formula, if you know, empirical formula is nothing but the molar ratio of the elements present, means molar ratio of carbon and hydrogen atoms. So to calculate the moles, we need mass of carbon. So when you simplify this one, it will be approximately 0.92 grams of carbon. So it means in the sample, this much, there was 0.92 grams of carbon, which got converted to 3.38 grams of carbon dioxide. All the carbon in the carbon dioxide is from the welding gas. Similarly, we will get the mass of hydrogen in the sample. Whatever hydrogen is there in 0.690 gram of water, that hydrogen will come from welding gas. It means in welding gas, same amount of hydrogen was present. So you will write it for H2O, you have 2 into 1 plus 16, that is 18. It means 2 into 1 2 grams hydrogen is there in 18 grams of water. 2 grams hydrogen present in 18 grams of water. So you will say as 18 grams of water contain 2 grams of hydrogen. Hence, whatever is given amount 0.690 of water would have contained 2 by 18 into 0.690. And when you solve this one, you will get 9. Yes, 0.07063 6 6 okay, 0.0766 grams of hydrogen. Okay. Now we know the amount of carbon 0.92 and amount of hydrogen 0.0766. Now we will apply the same method to calculate the empirical formula that we have carbon and hydrogen. First we will have mass, then we will have the moles. Okay, that is molar mass, you can write here. Then moles, then simplest ratio. Okay. Ratio and then simplest ratio. First ratio and then simplest ratio. So carbon is 0.92 grams, hydrogen is 0.0766 grams, molar mass 12, molar mass 1. Remember why I am writing 1? Tell me, okay, I am asking to, okay, Kshitij, tell me why I am writing 1. Okay. Tell me, Pratyush, why I'm writing 1. Okay, Samad, you have raised hand, yes.
So maybe because it is actually the molar mass of hydrogen.
Okay. Uh, I'm looking for some keyword here. Why I have written 1? Tanu, yes. Tell me.
Sir, because we are considering atomic mass here, single atom.
Correct. In empirical formula, we are always considering atomic forms, never molecular forms. And that is the key, not to make the mistakes. Always atoms. So hydrogen I am considering here as atom. Atomic mass will be 1. So I have written molar mass means 1 gram per mole. Means moles will be 0.92 divided by 12, given mass divided by molar mass. Okay. You can write here atomic mass because this will always be atomic mass. To make sure that you don't make mistake, you can write atomic mass. And it will be 0.0766 divided by 1. Basically, when you solve this one, it will be 0.0766. This will also be 0.0766. Here it will be 7766. Approximately same, means simplest ratio is 1:1. Okay. 1:1. So once you get the mass of carbon, mass of hydrogen, after that you will apply the same knowledge, what you already know, to convert the mass into moles, and then the molar ratio, then the simplest molar ratio. If it is 1:1, it means the empirical formula is CH. C1H1, 1 is not written. Okay. Empirical formula is CH. Shivani, mute your mic. I'm muting you. Is that clear? Now, empirical formula, you know. Now, the key part to calculate the molar mass, and which is very important to understand. The question says, a volume of 10 liter weighs 11.6 at STP. And you know, by definition of mole, that 22.4 liter will be equal to molar mass. Is that clear or not? 22.4 liter will be equal to molar mass because 22.4 liter is 1 mole at STP. So whatever will be the weight of 22.4 liter of the gas, that will be equal to molar mass because that is mass of 1 mole. And you have been given the mass of 10 liters. Again, apply the unitary method. If 10 liters weigh 11.6 grams, then 22.4 liter, that is 1 mole, will weigh how much? That will become the molar mass. Any confusion, let me know here. It is important to understand this point. The definition of mole is 1 mole is equal to 22.4 liter of a gas at STP. And 1 mole also says that 1 mole in grams is equal to its molar mass. So I'm explaining it, understand? Mole, 1 mole is equal to 22.4 liter of gas at STP. But 1 mole is also equal to molar mass in grams. These 2 points you know already from the diagram. It means if I can calculate the mass of 22.4 liter of gas, that will be equal to molar mass of the gram of the mole, that gas. Any confusion? Ask. These two are equal things. What I have been given that 10 liters of gas weighs 11.6 grams. I will calculate the mass of 22.4 liters. That will give me the molar mass of gas. This will be the molar mass of the gas. Yeah. So that is the second part done. Second part was molar mass. The moment you have molar mass, okay, when you calculate, this will be 11.6 into 2.24, and it will be approximately 26, okay, grams. It means molar mass of the gas is 26 grams per mole. That is the definition, 20 grams per mole. Whatever grams are there in 1 mole, that is the molar mass. So you got molar mass 26. Empirical formula CH, molar mass, that is molecular formula mass 26. Not empirical formula mass. Empirical formula mass will be 12 plus 1, 13. Molar mass is 26. You need to get the factor by which you need to multiply the empirical formula to get molecular formula. N is molecular formula mass divided by empirical formula mass, that is 26 divided by 13, that is 2. It means molecular formula will be 2 times CH, that is C2H2. And C2H2 is ethyne. So the answers will be empirical formula CH, molar mass 26 grams per mole, molecular formula C2H2. Is that clear, everyone?
Yes.
So can you please show
Yes.
the
Yes.
second slide once again?
This one,
Yes. No, sir, no, sir. So the other one.
that was the temporary one. What you couldn't understand, just let me know. I'll explain again.
Nothing, sir. I was just copying it.
No, no, don't
Empirical
copy. You
formula.
have to do it. This question in assignment, so don't copy.
Okay, sir.
And if there is any confusion, just go through the recordings. First, try to do it yourself. So everything should be clear here. No confusion should be there. Just go through the question again. Try to understand what is given, what approach we followed. And then when you solve the assignments, don't consult any book, internet, etc. Try to do it yourself. Then you will be able to do it in examination.